Type of ground, firm, sandy. So earthworks excavations is basically governed by the different types of conditions we experience. Now, if your ground is firm, what does it mean? It means that the machine has to work harder. Naturally, if the ground is sandy and very soft and loose, the machine does not have to work as hard as it was with firm ground. Now, this has an implication on a couple of things. One, cost, and two, duration. Remember, harder, therefore it's going to take longer. All right? And if it's going to take longer, it's going to cost more. Also, if it's harder, it's going to work more, which means it's going to use longer fuel. It's going to use more fuel at a longer period. So fuel cost is going to go up. Naturally, the operating cost is also going to increase because the time taken is more than it would have been if it was loose soil. Right. Why is groundwater? Firstly, what is groundwater? Groundwater is the water table. All right. Why is groundwater condition for earthworks and excavation? All right. If you're working close to the ocean, every time you dig a little hole, it fills up with water. You dig a bigger hole, it's going to fill up with water. So to continue working, you need to have to put in some sort of pump to suck out all that water. So there you go. Groundwater is an issue for earthworks. And almost all instances has a cost implication. At season. Why is season an issue? There you go. If it's raining, can you work? Another question. When the rain stops, can you still go back to work? No. If it rained hard enough, then you're going to have to wait for a couple of days for that water to subside, so that the site is actually walkable. Haul distances. Whatever you excavate, it needs to be taken someplace. Do you take it a few meters away? Do you take it kilometers away? And therefore, you see how the cost starts to climb when it comes to earthworks and excavations. Right? Bulking. Determine the volume to be handled. Now, bulking, we'll talk about that when we start the calculations. All right, but bulking is basically disturbing the soil and introducing voids. And that has an implication on volume. All right, we'll come to that in a moment. All right, principle of calculating a labor constant. Labor constants have been established historically over a number of years. Example, 6 laborers excavate 22 cubic meters in 1 8-hour day. We've established that previously when we started. Therefore, the labor constant to perform this task is as follows. Number of labor hours per meter cube divided by 22, and you get 2.18 hours per cubic meter. All right, excavation by hand, naturally more difficult, more longer. The table below shows some labor constants for excavation by hand in normal conditions in ordinary ground. Excavate and load into barrows, unit is cubic meter, 2 hours. Wheel and deposit within 50 meters, an issue length, as we said, haulage. Remember, haulage is not only for mechanical plant, but also, in this instance, by hand, 1.5 hours per meter cube. All right, spread and level, return, fill, and compact. Other activities when it comes to excavation. As dug, which actually should read something like that. As dug is the volume of ground before excavation. We assume an average bulking of 35% for calculation purposes. This is going to change, and it's going to change depending on the type of soil. You will see in the calculation it's coming out. However, this value will vary according to respective soil conditions, as I've already mentioned. This needs to be allowed for when pricing for handling of bulk materials. The tender rate, however, is for materials in the compacted form. That's scary. Because if we dig in this hole, we know the dimensions, we know the volume, and from that we can get volume. All right, I'm only paying for that volume. I don't care if you use 10 trips with 10 tracks, 5 trips with 10 tracks, 20 tracks with 2 trips. I don't care. I'm paying just for that amount to be excavated. That's what this line means, strictly. If a factor is not provided, the factor above applies. So if I don't give you a bulking factor, use 35. That's what I'm saying. Excavations are usually in stages of 2-meter depths. The table below gives labor constants for excavations by hand in depths of increments of 2 meters. Excavation exceeding 2 meters, not exceeding 4. All right, you've got limits. 2, 4, labor constant is 5. Excavation exceeding 4 meters, not exceeding 6, 8. What's happening here? The deeper I go, the longer it takes to do 1 cubic meter. Why? Because think about a hole like that as opposed to a hole like that. And the guy is busy in here with his pick and he's digging. And then he has to throw it all out there. And he throws it right there and falls back in. As opposed to a guy in this hole. Now you see why depth is an issue. Loaded excavated material on the truck, 2 hours per cubic meter. Right? By then, whatever material, it's loose. Right? Easier to scoop it up and throw it into the truck. Always remember the following. Labor constants vary. Preceding tables are used as a guide only. The method of determining a labor constant is to ascertain the volume excavated by several workers in one day, and from this to calculate the labor constant is to be used in future tendering. Labor constants are total hours divided by production. All right, example 1, calculate the cost per cubic meter to excavate a trench 1.5 meters deep in gravel if 30% of the excavation must be returned, filled, and compacted. The rest is to be carted away. Deposited, spread, and leveled on site, the soil bulks by 35% and the labor cost is $5 an hour. Very cheap labor. All right, activity, excavate, load into barrels, labor constant, and you can see how we arrive at cumulative labor constant. All right, unit labor cost is equal to 4.5 hours per cubic meter at 5 Rand, and we have a cost per cubic meter. And we said 1.5 is the bulking factor. All right, now this calculation, I'll be honest with you, this calculation is for illustrative purposes only. All right, I've seldom given you a question in a test or exam of this nature. For example 2, this starts to get complicated now. All right, so let's pay more attention to this particular one. Calculate the cost of excavating ordinary ground that has a bulking factor of 35% by hand, loading into a 6 cubic meter truck by hand, and carting to a municipal tip 3 kilometers away. Assume that the overall is not measured. The following information is given. Hired truck is 750 per meter cube per kilometer. Municipal tip charges is 40 Rand per load, and the labor constant for loading the truck is 2 hours, and the labor cost is 5 Rand per hour. All right, so excavate and throw, you got something there, 2 hours per cubic meter at 5 Rand. There's a cost there. Load onto truck and cart away, 1 trip. Truck, labor loading, truck cost, tipping cost, all given in your question. Unit truck cost given as that, and we arrive at a cost for excavating and carting it away. This, mind you, done by hand. All right, 1.2.3, page 16, mechanical excavations. The selection of machine depends on the type of work that needs to be done. All right, bulldozer is used to remove topsoil. We'll start with topsoil in quantities and do calculations in this regard. Excavate in bulk not exceeding 300 millimeters deep and deposit this material in spoil heap. It is also used to spread material from the spoil heaps onto site and for ripping hard material. This type of machine is not allowed on South African roads and need to transport to site. Scraper is used for the same purpose as a bulldozer. However, the areas covered and the volumes moved are far greater. This type of machine is not allowed on South African roads and needs to be transported to site. Front end loader. It is used for bulk excavations in soft material that is in the same level as the machine and for loading excavated material onto vehicles. It has, in most cases, 4 equally sized tires. These types of machines are not allowed on South African roads and need to transport to site. All right, back actor or back actor excavator, TLB, very, very versatile machine. See it everywhere on construction sites. This versatile machine, that's why, is used for trench excavations and for excavations that are not on lower level than the machine. There's 4 tires and in most cases, 2 different sizes, and hence their tire cost shall be indicated as a set. All right, this type of machine is allowed on minor roads for short distances. That's why you sometimes have to follow it on the road because it travels very slowly. All right, due to the nature of these vehicles, they are strictly not used for human or material transportation, and due to the design, not capable of doing long distances on their own. All right, in order to calculate machine excavation cost, we need to know the machine's output. Where do we get that from? The output of a machine is the quantity of a material moved by the machine to a point of deposition. Deposition, where we dig it, or we carry it from here and we take it there. The tables below are guidelines of outputs in normal material. Now it starts to get complicated. All right, however, if we work in stiff clay, weathered granite, or shale, we need to reduce output by approximately 12%, 20%, and 25%. Also, the tables below for excavations not exceeding 1.5 meters deep. For additional 1.5 meters depth, the output should be reduced by 20%. Right, all this will make sense in a moment. Outputs are measured in cubic meters per hour. A bankman is a person who directs the operator. Remember I said operating cost? We need somebody to use the machine or work the machine. And sometimes he may need somebody to help him that's walking on the ground so he doesn't crash or into other items, crash into other buildings or other structures. All right, from the ground because of his location in the vehicle. It's hard for him to see. His wages should be included in the cost as a cost of the excavation in the unit rate. All right, here's your tables. This is for your scraper. Let's look at table 2. The bucket size and the shovel size for a back actor. Right, now this is a table that I'm going to give you in your data sheet. Let's look at this one question. Question 2, page 10. I said quarter cubic meter back actor. Remember that? Why did I say that? Because I said the questions are going to get more complicated. If I gave you a quarter cubic meter back actor, you're going to go to this table and you look at a quarter cubic meter back actor. This is its capability per cubic meter, 8. All right, 8 cubic meters per hour. That's its capability. All right, truck type characteristics. Now, I want to stick to this table. If it is a 4 cubic meter truck, it has 4 tires. If it is a 6 cubic meter truck, it has 6 tires. If it is a 10 cubic meter truck, it has 10 tires. Right, the reason I'm sticking to this is because when we ran the national diploma and students came back from their in-service, some of them worked on construction site and we had numerous arguments over the number of tires for the volume or capacity of a truck because on site they saw something else. All right, so I'm going to stick strictly to this for our calculations. I'm not going to deviate. In any event, this table and this table is going to be in your data sheet.